All right, babies, it's time for another lesson. So for this time, we're going to mostly just be doing stuff that we did last time. We're just trying to get better at it. There's a lot of hard questions on this assignment. There's a lot of information you have to know. It's okay if you're not good at it yet. We're just trying to get better every day. This is kind of a list of the things we learned last time, with the exception of the redraws. We didn't get to that. But these are things that you do need to know the rules for. Similarity ratio, scale factor. What do you do with area? What do you do with perimeter? We're going to get to all of these things in this video. All right. So first, before we even start with all that, let's talk about numbers. Simplifying or solving equations, not using a calculator. I talked to you guys about how if you don't know how to break things down, math eventually gets really hard for you. If your instinct is to pick up a calculator when you see this stuff, I want you to try really hard to not do that and think about things you can do to break it down. So let's start with this one. I don't actually know what this is, but I do know that I can pull out numbers that are easy to divide by. I'm looking at the numbers 36 and 240. I know that I can divide these by 6 pretty easily. 240 divided by 6, 240 divided by 6 would be 40. 36 divided by 6 would be 6. So it reduces to 40 over 6, which is a lot easier to reduce. I can divide this by 2, giving me 20. Divide this by 2, giving me 3. So 20 over 3 is the same thing as 240 over 36. You don't have to pull out a GCF. You just have to pull out an F, a common factor of any kind. Sometimes people sit here forever trying to pull out the GCF, and it takes a long time, and they can't figure it out. Just pull out any common factor and keep going forward, and you're going to figure out the answer. Over here, we talked about last time how we can reduce vertically, but we can also reduce horizontally. Reduce first, then solve. We're trying to solve for x here. There's a lot of choices here. I'm just going to go through and reduce as I see them. You could do it a different way than I am, as long as you're using your reducing rules correctly. Like I see horizontally 12 and 24 would reduce to 1 and 2. So I'm going to scratch those out. 4 and 2 would reduce to 2 and 1. So this is just gone now. I have 10 and 42. Could divide by 2, I get 5. Divide by 2, I get 21. What else do I have here? I got a 5 over here and this 5, so this number is just gone and this number is just gone. 3 and 30. 30 divided by 3 would be 10, and this 3 would just be gone. 44 and 11. The 11 and the 44 reduces to 1 and 4. That 11 is just gone. I have an 18 and a 21, so I could do work with that. 18 divided by 3 is 6. 21 divided by 3 is 7. Oh, and I have a 7 over here and a 7 over there, so that number is just gone. When I say it's gone, it's the number 1 now. Here I have a 2. Could be basically just this goes away, and 4 would become a 2. Here I have a 2, it would just go away, and 6 would become a 3. Here I have a 2, would just go away, and a 10 would become a 5. And yeah, so I'm left with 5 times 3 over 1 equals x over 1. Well, that would just, x would then equal 15. So x equals 15 on this situation. So it's a whole bunch of just simplifying. Remember, you can reduce horizontally or you can reduce vertically. So there were other options besides what I did, but all paths lead to x equals 15. All right, moving along. This is the new situation. It is, I think, pretty tough. So let's see what we got here. And I just made up these numbers, and I'm looking at it now. It might not even work. Oh, no. That's okay. If it doesn't work, we'll talk about why it doesn't work. First, you have to realize, hey, we actually only have 2 triangles in this picture. And you have to identify those triangles and understand what you're working with. We have this big purple triangle. We like the big purple triangle. And then we have this smaller pink triangle. We like the small pink triangle. At least I do. So we have a big purple and a small pink. And we got to realize which sides correspond to each other. The problem is that they're not drawn the same way. Here's what we know. we know that this angle matches this angle. They put a little 1 dash in there, great. We have a shared angle. Don't pink and purple both use this corner? I'm going to put a 2 dash in this corner. Some people like to use dots. Like call this a 1 dot, call this a 2 dot. And if 2 angles match, doesn't the third one have to match? That means that the third corner, I'm going to put a triple. The third corner, I'm going to put a triple, or you could put 3 dots if you like the dots better. But just some way to distinguish which angles are which. Something else I'm noticing on this picture is there's no labels. So I'm going to call this A, I'm going to call this B, C, D, and E. And what I'm going to do is redraw the 2 triangles. I'm going to start with the big purple one. And I'm going to draw a triangle that looks a lot like it. Face it in the same direction as the big one. I usually try to mimic the big one. The big one has corners of E, A, and C. And I put this one as my 1 dot, this one is my 3, and this one is my 2. And I'm looking real carefully. Okay, here's my 1 dot. What is across from my 1 dot? It would be this entire side. How long is that entire side on this picture? It is 6 plus y. From A all the way to C would be this part plus this part to get that whole thing. The left side, 2 dots, across from the 2 dots, just focusing on the big triangle, across from the 2 dots would be the side they called X. And then finally, across from the 3 dots would be this entire side, 5 plus 3, the entire thing, 8. Woo, that's tough. But it is this entire side that is across from this angle on the purple triangle. Then I'm going to do the same thing with the pink triangle. Here's the thing about the pink triangle. I want it to face the same way as the purple one. That's the whole reason we're doing a redraw. So my angles are going to be 3, 2, and 1, and I'm going to put them in the same corresponding corners. But look, they're in different spots. So like my 3 dot would be across from 6. So I need to make sure that my 3 dot is across from 6. My 1 dot is across from 3. I need to make sure that my 1 dot is across from 3. And then finally, my 2 dot is across from 4. I need to make sure that my 2 dot is across from 4. So those are the sides. Once we've redrawn it so that the angles are in the same position, we can start making ratios. We know that 6 plus y goes with 3. We know that x goes with 4. And we know that 8 goes with 6. Well, the only one we know where we have a complete set is the 8 and 6. So I would reduce that and make that 4 over 3. And I would do 2 different proportions. 4 over 3 equals 6 plus y over 3. And 4 over 3 equals x over 4. Perfect. So I use that 4 over 3 ratio over and over again, and I'm seeing a problem, guys. Well, the 3's cancel out, leaving me with 4 equals 6 plus y, so y equals -2. That is an issue. I will fix that for class, but could this number be -2? Could this length be -2? And the answer is no. So I will fix that for the in-class lesson. But just know we did the process correct, but this would actually mean no solutions because that cannot be -2. Over here we solve, there's nothing to cancel out, so we have 3x equals 16 and x would equal 16/3, which could work. The problem is the -2 on the y. But we're going to have questions like this, guys. Figure out, I think the easiest way is to base it off the angles. You don't have to redraw it if you can see it without redrawing it. Like if you recognize, ooh, the 1 is across from 6 plus y, and then over here, you know, the 1 is across from the 3. So you know 6 plus y goes with 3. If you can see that without redrawing it, go to town. I don't care. All right, the rest of these are ones we did last time. I'm going to go pretty quickly, but pay attention, see if you can do it. Pause the video, see if you can do it from your memory, and let's go. All right, it says find BC. Well, BC is not labeled, so guess what I'm going to do? I'm going to label it. I'm going to call BC X. That means that this part has to be 30 minus X. How do I know that? Well, if this was 10, wouldn't I know this is 20? Wouldn't I do 30 minus 10 and call it 20? It's not 10, it's x. You treat x just like you treat any other number. So I know that this has to be 30 minus x. And our rule for angle bisectors is that the two sides, 18 and 24, the two sides that touch the angle bisector, have the same ratio as the two parts of the opposite side. So if I do top over bottom, 18 over 24, I got to keep doing top over bottom, and that would be 30 minus x over x. That is my proportion for the angle bisector. Reduce first, divide by 6 would be 3, divide by 6 would be 4, and that's all I can do. So then I cross multiply. 3 times x is 3x, equals 4 times 30 minus x. So we have 3x equals 120 minus 4x, 7x equals 120, x equals 120 over 7, and that cannot be reduced. 120 is not a multiple of 7. So since we called BC x, right, isn't that where we put the x, then we're done. We got the answer. That is what x equals. If I asked you how big is AB, just to be clear, AB would equal 30 minus 120 over 7. So AB would equal 210 over 7 minus 120 over 7. AB would equal 90 over 7. I did not ask for that, but if you had to get it, that's how you would do it. All right, next picture. Oh, I need to fix this. I should have said that these are parallel. I'll fix that for class. Woo, finding all kinds of mistakes. So these lines have to be parallel for this to work, for our example to work. This is our parallel line properties. Our parallel line properties say that the pieces between parallel lines have the same ratio over and over and over. So I know that 9 over y has to equal 6 over 5. I can do these pieces, I can keep doing top over bottom, any combination that I want. So solve this, 6 and 9, I can reduce horizontally, 2/3. So I know 2y equals, cross multiply, 2y equals 15. So y equals 15 over 2. So there's y. Now here's the harder part. We have to solve for x. X is on one of the parallel lines. I highly recommend, until you get really good at this, that you redraw these triangles. So the big triangle has a side of x. This side would be 15, and this side would be 50. Ooh, that's interesting. We're going to have to find out how long that side is. We just said y is 15 over 2. So I have to, real quick sidebar, I need to do 15 over 2 plus 5. So that would be 15 over 2 plus 10 over 2. So that would be 25 over 2. So this side would be 25 over 2. 25 over 2. All right. So we've got lots of good stuff going on here. Love it. The small triangle has sides of 9, 7, and y, which we just said y is 15 over 2. All right, so this is the small triangle here. Now, you don't actually need all the sides, but I did label all the sides. I don't think I actually even need that 25 over 2 that we got. But once you draw the triangles, it's easier to see how to solve for x. We can do x over 7, right over right. And I could use these two numbers, but one, they're not whole numbers, so they're harder to use. But also, it's possible we did this wrong, like thinking about on a test, maybe we messed up somehow. Do we want to use our incorrect number now? Ooh, that might be tough. Don't use the number that you just got unless you have to. Can't we use these numbers, which were given to us, which we know must be correct? That is the better path. So we did top over bottom, x over 7. We're going to do top over bottom, 15 over 9. That is the best way to do this. Reduce, divide by 3 would be 5. Divide by 3 would be 3. Cross multiply, 3x equals 35. So x equals 35 over 3. And we got it. But if you're using the actual parallel lines, you have to focus on the triangles. It's a different property that makes that true. All right. Number 3. I'm going to go ahead this is, get rid of the picture. Oh no, probably shouldn't have it there. That's okay. That's okay. That was my buddy there. All right, so we got my friend Griffin. He's 5 feet 6 inches tall. His shadow is 10 feet long. So I got a guy standing up, and he has a shadow. Shadows are on the ground. So here's the situation for the first one. We have person and shadow. Actually, we don't even need that hypotenuse, but person and shadow. We have a flagpole. That would be standing up. And its shadow. So what do we do? Well, first I see feet and inches. It's probably easiest to do everything in terms of inches. So hopefully we know that 12 inches is equal to 1 foot. So 5 feet. How would we go from 5 feet to inches? This would be 5 times 12, so that would be 60. And there's another 6. So Griffin, I'm going to rewrite as being 66 inches. Boop. 5 times 12 is 60, so this is 60 feet plus another 6 inches. He is 66 inches. All right. And his shadow is 10 feet. I'm going to make that inches. 10 times 12 would be 120 inches. Down here, the flagpole is 20 feet. 20 times 12 would be 240 inches. All right, so Griffin's height is 66 inches. His shadow is 120 inches. The flagpole's shadow is 240 inches, and we're looking for its height. So I converted everything to inches first. And now I have to set up a proportion. If you do height over shadow, you need to keep doing height over shadow. If you do height over height, if you keep doing left shape over right shape, keep doing left shape over right shape. Keep going, keep going, keep going. All right, so how are we going to do this? 66 over 120. I'm going to do height over shadow equals height over shadow. I need to reduce, these are some big numbers, I don't want to multiply those out. Well, 120 and 240, nice. That's just 1 and 2. Well, that just made it real quick. That just made it real quick. Love it. X times 1 is X. 66 times 2 would be 132. And that is 132 inches. Remember, we did everything in inches. What if the question said to answer it in feet? Well, you would do 132 divided by 12. Ooh. Do we know 132 divided by 12? Do you? If you didn't, well, hopefully you do. If you don't, that's okay. Sometimes you don't know the full thing. That's okay. We talked about this earlier. Break it down into numbers you do know. Let's say you don't know what that is. Could you divide by 2? 132 divided by 2 would be 66. 12 divided by 2 would be 6. Now, do you know 66 divided by 6? Would that be a little bit easier? Perhaps. But no matter how you do it, you get x equals 11 feet. So it's 132 inches or 11 feet. Woo! That's a lot of work there, my friends. A lot of fun work. All right, we got my friend Abby here. We're making a statue of my friend Abby. It says Abby has a surface area of 200 units squared. Surface area that's his current surface area, but someone's making a statue using the ratio 5:3. So remember we talked about this. The ratio, if it's a similarity ratio, that means it's a linear ratio. It's a ratio that compares things that are lines. Is surface area measured in a line? How do you get area? What do you count? You count squares. So it's 5 units to 3 units, but we need to use unit. We need it to be in units squared. So to work with area, you have to square the similarity ratio. We talked about this. So that'd be 25 units squared for every 9 units squared. That's the ratio we're going to use. So it's going to be 25 over 9. It says he's making a statue of Abby, used a 5:3 similarity ratio, equals 200 over something. Whew. That is our setup. If you use 5 over 3, it's going to be incorrect. 5 over 3 is the similarity ratio. We needed an area ratio. You can't work with area unless you have an area ratio. One of the worst things you can do is like square or square root the area. That's not what we're doing. We're using the ratio. We square the ratio. So reduce 25 and 200 would be 1 to 8. Cross multiply, x would equal 72. But you gotta square that ratio. Would you rather sugar is a healthy food and you need to eat it a lot, or you can read and remember any book in 10 minutes? Ooh, I like candy too much. If sugar was healthy, like imagine sugar being like your broccoli and your carrots and all these healthy foods. Oh man, that would just be the life. I'm going all day on that one. Would you rather fly or your body doesn't need sleep? Well, I'm terrified of flying, and that would be really cold. I would love to stay up all night, poning noobs, playing some League of Legends, having fun. Yeah, sleep is for the weak. No, I'm just kidding. You got to get enough sleep. I wish I didn't have to sleep, but man, whew, you got to get that sleep. I'll be so cranky without sleep. All right, friends. Angle bisector property. We had one of these already. The angle bisector property says that the two sides that touch the angle bisector have the same ratio as the two parts of the third side. You have a lot of options here, but I'm going to do left over right, 5 over 4, equals left over right, x over 10. Remember that there's 4 ways to do every proportion. You could have done 5 over x equals 4 over 10, and there's a couple of other options. So this is the way I chose to do it, and this way is correct. 4 and 10 reduced to 2/5. Cross multiply, 2x would equal 25. X equals 25 over 2. You have to know that property to solve this. This is not a triangle redraw. This is not what we did earlier. This is an angle bisector problem. Here we've had this one already, but let's do it again. It's per parallel line proportions. There's a very strict situation here. The first one is that all the pieces between parallel lines have the same ratio. So x over 2 has to equal 7 over 4. Left over right equals left over right. Again, you could have done x over 7 equals 2 over 4. You could have done top over bottom equals top over bottom. There's 4 ways to do every proportion. 2 and 4 reduced to 1 and 2. So 2x equals 7. So x equals 7 over 2. Okay, but then we have a second situation where we have to solve for y. Parallel lines, we would have 5 over y plus 10. And I'm going to avoid this side because there's an x on it. I'm going to go with the side that has known quantities. 5 over y plus 10 is going to equal 2 over 6. There's a man, there's no 6. Where's the 6? There's a man. Listen, I understand. It's hard. It's hard. It's okay. We have a small triangle. I'm going to draw it in red that has sides of x, 2, and 5. We have a bigger triangle. I'm going to draw it in blue. The bigger triangle has sides of 6. 4 plus 2 is 6. Y plus 10, and 7 plus 7 halves. 7 plus 7 halves would be 14 halves plus 7 halves. That would be 21 halves. So I did 5 over y plus 10, bottom over bottom equals right over right, 2 over 6. If you're using the actual parallel lines, you have to focus on the triangles. Now we reduce. That's 1 to 3. Cross multiply. This would just be y plus 10 times 1 equals 5 times 3. So y equals 5. Nailed it. Parallel line rules. And then another area question to wrap it up. It does not matter what shape it is. Area must use a squared ratio. A ratio that is squared units. Perimeter is linear units. Area is units squared. So the ratio of the area, the perimeters rather, is 100 to 30, which reduces to 10 to 3. That is a similarity ratio and a perimeter ratio. Those are the same ratio. They're both one-dimensional, 1 degree linear ratios. They're lines. Perimeter is how long it is if it was a line. So how do we get the area? We have to take this ratio and square it, 100 over 9. And now we can set up a proportion for the area. Now I did big over small. I did left over right, so I need to keep doing left over right. So 100 over 9, when I square those, right, 100, 10 squared over 9, 3 squared, equals left over right, x over 25. Nothing reduces, so we get 9x equals 2,500. So x equals 2,500 over 9. And the awesome thing is if nothing reduced here, they're not going to reduce here, guys. So we know we're fully reduced. So the area would be 2,500 over 9. That's the last question on here. That's a quick recap of a lot of the stuff we learned last time. Not everything, but a lot of things. Whew! All right, time to do your homework. Good luck, my friends.